Okay, so now we're very happy with what we do when we have a right angled triangle. What about what we do when we have a non-right angled triangle? So let's have a look. Let's draw a nice big non-right angled triangle. Okay, in this example, we're told that this side is 32 degrees, this side is 14 centimetres, and the base is 25 centimetres. And we're asked from that to actually work out everything else. We're told to find side A, angle B, and angle D, because C's look a bit rubbishy. So, how on earth do we do it? Well, there's a little trick we can use. There's actually lots of different ways we can do it. And we'll see a couple of different ways in a minute, but a nice easy way that you can do right now is to create two right angle triangles. Now, any triangle can be made up of two right angle triangles. And we show that by dropping a perpendicular, or basically dropping a straight line down from the top of the triangle all the way down to the bottom to meet at 90 degrees. Okay, so now all of a sudden we have our right angle triangle here where we can work out some stuff. Okay? Now, what do we want to work out? Well, we're trying to find the length of this side. So what we really need to do is find some of these angles and find some of these lengths as well. So, we start off, we're going to need to work out the height here. Okay? And we'll do that, let's remember our soccer tower for this one. Okay? Now, we're going to need, we've got the hypotenuse and we need the opposite, so we're going to need sine. So we're going to need sine theta is height over op. No. We're going to need sine theta is opposite over hypotenuse. So in this case, it's going to be sine of 32 equals question mark over 14. So 14 times by sine 32. It's a bit messy, isn't it? It's even messier. Sine 32 will equal our question mark, our height. So let's do that on our calculators. 14 times sine 32 is 7.4. So that tells us the height of our triangle. So that's 7.4. Now why on earth has that helped us? Well, we can actually say what this angle is in here as well, remember. It's going to be 90 minus 32. So we've got 90 degrees here. So this bit of the angle we can work out. Right, but anyway, so that's what our opposite is going to be. We can now work out what this proportion of this is going to be. We can just use Pythagoras, can't we? So we've got, remember, Pythagoras, h squared equals a squared plus b squared. Okay, so we find that 14 squared equals a squared plus 7.4 squared. So remember what we need to do. In this case, we need to get a squared on its own, so we want to take 7.2 squared off both sides. Sorry, 7.4 squared off both sides. And that will cancel those out. So we end up with 14 squared minus 7.4 squared is a squared. So 14 squared minus 7.4 squared equals 141. So that's our a squared. So a equals the square root of 141. which is 11.9 centimetres. So that there's 11.9 centimetres. So this fraction here will be 25 minus 11.9. So 25 minus 11.9 equals 13.1 centimetres. So that's 13.1. So now we have two sides. You can calculate this side. So here we go again. We've got this time a squared plus b squared equals h squared, and h squared is what we're working out. So we've got 7.4 squared plus 13.1 squared equals h squared. So 7.4 squared plus 13.1 squared is 26.4. So h just equals the square root of that, which is 15.04. So 15, basically. Sorry, square root of h equals square root of 2 to 6.4, which equals 15, roughly. Okay? So now we know this side. And we can now go on and work out this angle. Okay? So now we know that A is 15. We know this length, we know this length, so I can work out this angle. So use whatever I want. So like I said, I always prefer tan for some bizarre reason, so we use tan of theta equals op over adj. Okay? So tan theta equals 7.4 divided by 13.1. So theta equals 7.4 divided by 13.1 tan minus 1, which equals 29.4. So 29.5 degrees. So I now know that this angle is 29.5. I know all my sides. I can now work out this angle. So this basically has got to be 180 minus 32 plus 29.5. So 180 minus, bracket on the calculator, 32 is 29.5, close bracket. This angle must be 118.5. So, just working through creating our two separate right angle triangles, we can work out everything on that diagram. And I know this board's incredibly fussy and incredibly messy, but I'm pretty much, all I wanted you to see there is that using any triangle, we can just split it into two right angle triangles and you can just apply all the knowledge you already knew. However, that is a long, drawn out, fussy process. My working looked all over the place by the end of it. There was lots and lots of different things going on. What you can actually do is use a couple of different rules, the sine rule and the cosine rule, which will make all of it a lot easier. But just in case in an exam you get flustered and you can't remember how to use those rules, you can always go back to your two right angle triangles. So now we're going to go over the sine rule and the cosine rule, and we'll see how we can actually make finding all those things on the diagram a lot simpler.